In this video, we're going to talk about multiplying and dividing whole numbers. And the first thing I want to talk about is the notation. You are all used to writing 5 times 7 with this x for the multiplication sign. But when we get to algebra, we don't want to use an x as a times sign because it can get confused with x the variable. So instead, we will also write 5 times 7 using a dot, or sometimes 5 times 7 with parentheses around either the 5 or the 7. And then as far as vocabulary goes, anytime you multiply, you have factor times factor equals a product. The answer to a multiplication problem is known as the product of that problem. And so when you have something like 3 times 4 is equal to 12, you can also reverse those and write that as 4 times 3 is equal to 12 because of the commutative property of multiplication, which we'll formally define in a little bit. But you can also write this in another order and say, if I go backwards and start with the 12, start with the product, and divide by each of the factors, you will get the other factor. So this would be 12 divided by 3 is equal to 4. Now let's specifically talk about the commutative property of multiplication. Basically it says if you have A times B, that is the same as B times A. If I use numbers, that would mean 3 times 7, for example, is equal to 7 times 3. As I mentioned when I described the commutative property of addition, commutative says we're moving the numbers around. And it doesn't matter which order we write those numbers in, we're still going to come up with the same product. Now again, when I write this with variables, that is the property, and when I insert numbers, it is not the property but an example or illustration of the property. And for the associative property of multiplication, we have A times BC is the same as AB times C. You can group the numbers how you want when you're multiplying. Notice it's still ABC on the left, ABC on the right, but we've grouped the numbers differently. As an example, I can have 3 times 4 times 5, or 3 times 4, then times 5. In both cases, on each side of the equal sign, we will get the product of 60. Now, for the distributive property, that combines multiplication and either addition and subtraction together. It's where you have a number out front, like A, being multiplied by B plus C or B minus C. Now, whenever you put something next to a parentheses, that means that that value is getting multiplied by what's in the parentheses. And here we're multiplying this A by both B and C. And I usually will draw those arrows out whenever I'm distributing, and so you can see physically, like a newspaper delivery person throwing the newspapers on someone's driveway, that we're distributing, we're multiplying through here. This becomes AB plus AC. And I did not put a multiplication sign between the A and the B because it's assumed that when two letters are right next to each other, they're being multiplied together. Now I also could have A times B minus C, which when you distribute would give you AB minus AC. Technically, this is known as the distributive property of multiplication over addition and the distributive property of multiplication over subtraction. It is a multiplication property, but we just usually refer to it as distribution. Now let's actually do some multiplication. In this case, we want to multiply 463 by 9. Now the process is that 9 is going to get multiplied by each of the digits in the number on the line above. We begin with 9 times 3. That is 27, but I cannot put 27 in a single digit position, so I put the 7 down and I carry the 2 up above. Then I take this 9 in the bottom right corner, multiply it by the 6 to get 54, then add on the 2 to get 56. Now I'm going to write the 6 down. The 50 part needs to be carried to the next column, so I put a 5 up there next to the 4. Then I do my third multiplication. 9 times 4 is 36, plus 5 is 41, and there's no other position up top to move that 4 to, so I can write the full 41 here, and the product is 4,167. Now let's just go straight to a larger problem. I'm going to begin with this 6 in the bottom right corner. I'm going to multiply 6 by each digit in the line above, in the row above. Beginning with 6 times the 7 above it, that's 42. I put the 2 down and I carry the 4. 6 times 8 is 48, plus the 4 that I carried is 52. I put the 2 down, I carry the 5. Then 6 finally times this 3 is 18, plus the 5 is 23. So I can write the full 23 down. But that's not my answer. I now begin with this 4 and I multiply it by each of the 3 digits in the line above, and I don't want these carries anymore, so I'm going to cross them off. Now technically that's not 4 we're multiplying by, that's in the tens column, that's a 4D. So I need to account for that 4D by putting a 0 here, and I'm really wanting to start one position over, so that's why I put that 0 as kind of a placeholder. Now we begin. 4 times 7 is 28. Put the 8 down, carry the 2 part of the 28. 4 times the 8 is 32, and then we add the 2 above it to get 34. Put the 4 down, carry our 3. 4 times 3 is 12, plus that 3 above there is 15. Now we add what's together between these two bars. We're going to get 2, 10, put the 0 down and carry the 1. 4 plus 3 is 7, plus the 1 we carried is 8. 2 plus 5 is 7, and then we bring down the 1. Now since it's a 5-digit number, I need to put my comma in here to group the 802 together and write this as 17,802. In this next problem, 10,000 is called a power of 10 because it's just a 1 followed by 3 zeros. When we have a multiplication by a power of 10, you can basically ignore those 4 zeros for the time being, take 43, multiply by 1 to get 43, and then take your 4 zeros and attach them back onto your problem to get 430,000. Now, if I were multiplying something like 43 times 20,000, that's not a power of 10, but we can use the same principle. I can hold off these 4 zeros until later, take 43 and multiply by 2 to get 86, and then reattach these 4 zeros to get 860,000. That's a nice little quick way of doing multiplication. In this next problem, we're asked to find the area of this rectangle. Area is a multiplication word, and in this case, we're going to multiply 7 times 4 to get 28, and centimeters times centimeters to get centimeters square. Now sometimes we write that as square with an exponent. Sometimes we write 28 square centimeters that way. The thing to watch out for is how this picture is labeled for you. Sometimes we actually write 4 centimeters there and 7 centimeters up across the top there because we can reuse this picture for both area and perimeter. If this is the case, don't multiply all 4 numbers together. Only one length and one width needs to be multiplied. And that is really the formula for the area of a rectangle. Length times width, or base times height if we want to use that vocabulary. If you are being asked to find the area of a square, that's just a special case of the rectangle. You're still going to be multiplying length times width or base times height, but since the base and the height are the same, you basically can say, oh, just in this case, 6 times 6. We usually write area is equal to side squared, and in this case, that would be 6 inches being squared, and 6 times 6 is 36, and we're going to have square inches because we're multiplying inches by inches.